All right, so naming acids. So first of all, let's talk about what an acid is. An acid is just a molecular compound that release hydrogen ions when dissolved in water. All right, so when we have acids, it's just the molecular compounds that release hydrogen ions when dissolved in water. Remember, a hydrogen ion, all it's saying is that I have an H with a positive charge. Hydrogen is in group 1, so when it turns into an ion, it forms a +1 charge. So what this means is, let's say, for instance, I have the acid HCl. First off, the way we write acids, they're going to be dissolved in water, and this is what this AQ stands for. AQ stands for aqueous. And all aqueous means is dissolved in water. So what this is saying is that if I take hydrogen chloride, which is just HCl, and I put it in some water, what ends up happening is it's going to break apart to just hydrogen ions plus some chlorine ions. They're floating around in the water, basically. So this HCl dissociates, and dissociates just means it breaks apart. And it breaks apart into its individual ions. In this case, I'm going to get a hydrogen ion, and that's what I mean by an acid. An acid is when you have a molecular compound, which usually involves a hydrogen in the front that's bonded to another nonmetal. And when you put it in water, it's going to break apart from that other nonmetal and just form a hydrogen ion. And we call it an acid. So we know acids mainly because they're going to have hydrogens in the front of the compound. They also have to have this AQ. This AQ means it's dissolved in water, which makes it an acid. Now, acids, some properties of acids is that they have sour taste. Acids can dissolve some metals. They have the ability to dissolve some metals. And you guys know some acids like lemons. Lemons are acidic, so are limes. Just these sour tasting things are pretty acidic. All right. So when you go to name an acid, and we'll get into acids a little bit more later, but when you go to name acids, They kind of follow the rule of ionic compounds. Even though they are molecular compounds, when we go to write their formulas, we still write it similar to an ionic compound, meaning we're going to switch their charges. So this positive one and this negative one had to cancel each other out to make it HCl, unlike other molecular compounds where you are just naming it by however many atoms you have of each. But there's two different types of acids that we're going to talk about. We have it when you have a hydrogen and a non-metal. So hydrogens that are bonded with a non-metal, and you know, most likely those non-metals are going to be like sulfur, fluorine, chlorine, bromine, iodine. These are the ones that are going to come up in this case. If you have hydrogen that's bonded with one non-metal, the way we name it is we end up saying hydro, and then we add an ic to the base name of the non-metal, and then we say acid. So for instance, like the example above, if I have HCl, that's an AQ next to it, I'm gonna name this hydro, and then my non-metal base name is chlor, and then I'm gonna add an ic, and then I say acid. So the ic and the hydro, and then the acid. So the scheme for it looks like hydro, base name or non-metal base name, plus ic, and then acid. So all my examples like this, if I have HBr, I'd say hydro, bromic acid. I'll put an AQ next to this to show that it's dissolved in water. Hydro, bromic, and this is all one word. I know it looks like I put a space here. This is all one word. Hydrobromic acid. What do you guys think this would be called if I had HF?
Hydrofluoric acid.
Hydrofluoric acid, thank you. Hydrofluoric acid. And then if I had HI with an AQ next to it, the way we say this is hydroiodic acid. All right, so this is the first type of acid we come across. Basically, anytime you have hydrogen in any of these. I'll even do H2S. Now, the reason this is H2S when I have hydrogen with the sulfur, so hydrogen with chlorine, bromine, fluorine, and iodine, these are all in group 7, meaning the charge for elements in group 7 all are -1. The charge for hydrogen is +1, so they cancel each other out. But when I get to sulfur, the charge for sulfur is 2-. So when I write its formula, I have to say H2S because I need 2 hydrogens with a +1 to cancel out that 2- for the sulfur. So this ends up being hydrosulfuric acid. You guys like to say hydrosulfic acid, and I'm okay with that as well. All right, any questions before I keep going? All right, if I keep going, this is one type of acid. The other type of acid that comes up is when I have basically hydrogen with a polyatomic ion. I have hydrogen and a polyatomic ion. Now, for instance, if I have hydrogen, we're still going to use the ionic rules where we have to like cross out the charges. We want the charges to cancel out. If I have hydrogen and the polyatomic ion nitrate, so the formula would look like HNO3, then I'd stick an AQ next to it to show that it's an acid. So the way we write this is the formula for it. If it's a polyatomic ion that ends in 8, so I'm going to say if the polyatomic ion ends in 8, that's ATE, switch to IC. So in this case, this is nitrate. It ends in ATE. It's with hydrogen, so that makes it an acid. I'm going to call it nitric acid. So I just changed the 8 to IC and made it nitric acid.
So you wouldn't say nitric acid?
No hydro. There's no hydro. The hydro is just for when you have a one other nonmetal. So let me even write that. It's just one nonmetal. When you have a polyatomic ion, which is a group of 2 or more nonmetals, you just say you change the 8 to IC. Now, if your polyatomic ion ends in "ite," for instance, like the polyatomic ion nitrite, when I write the formula for it, nitrite is NO2, and then I put an AQ next to it. If the polyatomic ion ends in ITE, like nitrite, switch to US, OUS. So this would be nitrous acid. Now, on the polyatomic ion sheet that I gave you, at the bottom of that sheet, there are some examples of a lot of the common acid names. And I'm just going to go through them really quickly. If we look at this sheet, and you see they all have hydrogen at the front, this is the same thing, the acetic acid. They have hydrogen at the front, so I'm going to assume that it's an acid. Now, in this case, this polyatomic ion C2H3O2 is acetate, so I changed it to acetic acid. This polyatomic ion CO3 is carbonate. When you write the formula, it's H2CO3, so I changed it to carbonic acid. So remember, if it ends in an 8, I changed the 8 to IC. Now this one here is just with one other nonmetal, and then that's why I have the hydrochloric acid. When you go over here, this is nitrate, so it goes to nitric. This is phosphate, so it goes to phosphoric. And this is sulfate, so it goes to sulfuric acid. Now, I just have a list of them here. They're just common acid names, but the rules still apply. You can still follow the rule. You don't have to memorize this or anything. You can just follow the rule. If it ends in 8, change it to IC. If it ends in "ite," change it to US. Now, if we look at some of these polyatomic ions, for instance, like hydrogen carbonate or bicarbonate, we have a couple of bi things. Even we have a bisulfate over here that starts with an H and a bisulfite. These are not quite acids. You see the difference in bisulfate, which is hydrogen sulfate, or sulfuric acid. You need one more hydrogen to make it sulfuric acid. So it's on the way to being an acid, but it's not quite an acid. So you just have to recognize, even though this has a hydrogen in the front of it, you'd have to know, okay, this is just HSO4. It's not quite sulfuric acid, or this is just HSO3. Okay, so some polyatomic ions, it looks like there's 3 on this list, do start with hydrogens, but they're not quite acids. We have to have the actual one I'm talking about, like H2SO4, sulfuric acid. Or you could have sulfurous acid as well. All right, any questions so far? That's just naming acids.
I'm
Okay.
sorry. I'm just confused as to how to, like when we have HCl, hydrochloric acid, how do we know that the H in hydrogen sulfate is not, I mean, is there just going to be an AQ on the end to say it? Or, I mean, are we just supposed to memorize it? Or
Say it again. How do we know that
it's,
if you have
it's
HCl
not
versus
that
what?
that H doesn't represent, that we don't look at that for an acid, because HCl is quite similar to HSO4. Is it just because it's with a
No.
polyatomic
Why are you
ion?
saying they're similar? That's what I'm confused on, I think. Why are you saying HCl and HSO4 are similar?
Well, they're both, the H's don't have, they don't look like they're having charges on them.
Okay, so that's, okay, I think I get what you're saying. This is a polyatomic ion. It has a charge.
Okay,
So
it's because
one-
it's a polyatomic ion. Okay, I got it.
That's how you know the difference. These down here, there's no charge. It's just, this is the balanced compound. There's no overall charge. These are still ions because they have these charges. So you just have to recognize, like if we were face to face, I'd have you guys memorize these things and you know, like, okay, HSO4 minus is not the same thing as H2SO4.
Oh, I'm totally on board. Thank you.
Okay, no problem. All right.
I have one question more.
Uh-huh.
If there is like ammonia, so it ends with the IA, and same way it is. If it ends with the IDE, so we use the same rule, or
So ammonium is not going to bond with another hydrogen because it's going to be 2 positives. Remember, we still want a positive and a negative. So the hydrogen is going to only look for the negative ones. And the only one that's really going to come up is when we have HCN in this case, and HCN is going to give us just cyanic acid. So that IDE is still going to change to IC, but I'm not going to make you guys know that about like cyanic acid. Does that make sense? Okay. Any other questions? All right, so let's look at this. Let's go to our naming acids worksheet. So it looks like this. It's under chapter 5. And we'll just do a few of these real quickly and then keep going with the lecture. So remember, I like these worksheets. You can always go back and reference them if you get a little confused. It tells you if you just have one non-metal, you're just going to say hydro, the root, and then ic and acid. If you have a polyatomic ion that ends in 8, you change the 8 to ic and then add acid. If your polyatomic ion ends in ite, you change the ite to us and then add acid. So you're going to have your polyatomic ion reference sheet, just because I'm sure you guys don't have them memorized or know them by now. But I just want to make sure you can easily find them. So for instance, if we go through the first one together, it's saying, okay, we have HCl, the cation for it, the positive part is hydrogen. That's going to be the cation for all of them. They're all going to be H pluses because they're all acids. The anion is either going to be one element or it's going to be a polyatomic ion. If it's one element, which is just one non-metal, remember all we're saying is hydrochloric acid. And so if it's a polyatomic ion, for instance, like this SO4, we're saying, okay, now the name of the anion is going to be sulfate. Sorry, where am I? Sulfate We changed the 8 to ic, and in this case, it ends up being sulfuric acid. So let me just write these down on a separate sheet of paper, and let's just go through how we're either gonna name them or write their formula. You guys can go ahead and get started if you have it in front of you. I'm just gonna write it down for those who can't quite print it out. All right, so number 1, this is naming acids worksheet. So the first one is HCl. We want to write the name. They give us the formula. I'm just going to do names and formula. I'm not going to do the anion and cation. This one says hydrofluoric, and I'll do the first 10. So if I write the name, that means I want you to write the formula. If the formula is already there, that means I want you to write the name of it. Then we have H2SO4. Oops. Number 7 says, what is that? Diana, do you have a question? Or were you just saying hi? Okay.
No, sorry.
It's okay. Okay, so when we look on the sheet, I'm just either gonna write the name of it or I'm gonna write the formula for it. So for the first one, we did this one already. This is gonna be hydrochloric acid. But then when we get to number 2, what do you guys think it is? Well, we did this one too. This is nitric acid. All right. Now we want to write the formula for hydrofluoric acid. What do you guys think the formula is?
HF.
Just HF. And technically we should have AQs next to them, but sometimes when you have worksheets, they don't always put the AQ next to it. All right, what about H2SO4? What do you guys think this should be?
Sulfuric acid.
Sulfuric acid. And that's mainly because this is sulfate. And remember, we change our 8 to ic. All right, so then if we have carbonic acid, we'd have to go look up what carbonate is, or just look over on our sheet and see what carbonate is. So what do you guys think the formula is?
H2CO3.
All right, H2CO3. We're gonna stick an AQ next to it. It's 2 here because carbonate originally is CO3 2 minus. So when we switch the charge, we gotta remember to put a 2 here for the hydrogen. Now, somebody else, let me hear what you think H2SO3 would be.
Is it sulfuric acid?
Yep, that's pretty much it, but we say sulfurous. Sulfurous acid. So you knew to change the this is sulfite. You knew to change the ite to us. And so it's sulfurous acid. All right, what about this chloric acid? What do you guys think the formula for it is?
Is it HCl?
It's H and then ClO3. I think you just forgot your oxygen. Chloric is gonna be chlorate, and chlorate, the formula for chlorate is ClO3. Don't get it confused with hydrochloric. So the difference here is that this is just chlorine and this is chlorate. So this is a polyatomic ion. This is just a non-metal. So you say the hydro for just the non-metal, and then you got to change your 8 to ic for the polyatomic ion. All right, what about phosphoric acid? What would you guys say the formula was?
H3PO4.
Okay, so yep, we have to remember that phosphate is PO43 minus. So if it's PO43 minus, when we go ahead and switch it, we have to say H3PO4 like this, stick our AQ next to it. And then does anyone recognize what this polyatomic ion is? I guess it tells you.
Oxalate.
So if it's oxalate, what would it be as an acid?
Oxalic.
Yep, just oxalic acid. Remember, we're just changing our ATE to ic. And then finally, for acetic acid, we're basically saying we have the polyatomic ion acetate, and the formula for acetate is going to end up
H3COO. Oh, that's wrong. My fault. Sorry.
okay.
The formula for acetate is CH3COO with -1 charge.
Yep.
So it would be H1.
Or you just say H. You don't have to say the H1.
Oh, yeah.
You just say H, and then you can say CH3COO. Or you could say the other way you write it is H, and you can say C2H3O2. But most of the time when you see acetic acid, they end up putting this hydrogen at the back. So it ends up being CH3COOH. So any of these ways of writing acetic acid would be fine.
Right, so basically if the polyatomic ions that has more than like a +1 charge or -1 charge, that's when you have to do the switch and add it into the name.
Yeah, yeah. So what do you mean add it to the name?
Well, let me see, which were we just on?
Do the switch, like for instance, for phosphoric acid, that's originally phosphate, and phosphate is PO43 minus. So I switched this and made that H3PO4, but that's it.
Yeah, and then for like the carbonic acid, kind of did the same thing, right?
Yep.
Okay.
Okay.
I have a question. When, let's see, for oxalic acid, when we're writing the cation, it's just going to be an H plus, not that H2.
So oxalic acid, when we go look at the polyatomic ion for oxalate, oxalate actually has the formula. Look, if we look on our sheet, it has the formula C2O4, 2 minus. So that's why I had to put a 2 right here, because this is originally 2 minus, and this is +1. So when you switch them, it ends up being H2C2O4.
So what I'm saying though is when we write it in the cation, we write H2 or just H?
No, you got to write the H2.
You have to write the H2.
Oh, no, sorry. I get what you're saying. You're saying in this chart. I would never give a table like this. I don't like the fact that it made you break it apart, but no, you can just write that cation. Where is it? Oxalate, you'd say H2, you'd say H plus. And then this is C2O4, 2 minus.
Okay.
If that makes sense. So then when you switch it, you say, oh, I need 2 hydrogens for every 1 oxalate.
Okay. So on this chart for what you just demonstrated, then all of the cations are just going to be H plus.
Right. Okay. Any other questions? All right, so that's naming acids. The homework, there's a couple of questions on naming acids. I want to go through one last part about chapter 5. So we basically just learned how to write the names and formulas of all the different compounds we're going to come across in this class. And let me grab another sheet.
So for this, I'm sorry, I just got in, Professor, I'm sorry. For this, I will be able to just look over the notes, right? And I'll be okay.
Yeah, and then send me an email if you have a question.
Okay, sounds good.
All right, so then we talked about molecular compounds. I want to talk about some common names for molecular compounds. And remember, guys, even though acids follow ionic compounds when you're writing the formula, they are still considered molecular compounds because hydrogen is a nonmetal and everything else that they're bonded to are nonmetals. So they can get a little tricky, but they're considered molecular compounds. Some other molecular compounds that we come across have common names. Some have common names, and you don't use any of these rules. You just call them their common names. So for instance, H2O, we all know that this is just water. We don't call this dihydrogen monoxide. We just call it water. Another common name that we come across is methane. Methane is a gas. So I'm just saying methane gas. It's a gas that comes into our home to heat up our home. And even the gas that comes into our stove, you know, if you have a gas stove at the house, that's methane gas that's coming out, and then you're hitting a spark and getting the fire for your stove. So we call it methane. We don't say carbon tetrahydride. And then the other one is ammonia. And that's only your polyatomic ion sheet, but it's not a polyatomic ion. It just, the common name for it is ammonia. Okay, so then we also have what is known as molecular elements. And molecular elements are just elements, hold on. Molecular elements are just elements on the periodic table that form molecules as their natural state. So molecular elements, for instance, we call them diatomic molecules. Those are the main ones I want you guys to come across, but it's a molecular element versus an atomic element. Atomic element, it means that you have just the individual atoms like lithium, sodium, potassium. Most elements are just atomic elements, but some elements in their natural state in our planet or universe in general, when you find them, you're never going to find them by themselves. You're always going to find them in a molecule. So for instance, hydrogen's an example. You're never going to find hydrogen just by itself. It's always going to be H2. So this H2 forms a molecule. Basically, it's saying I have two hydrogens connected to each other, which forms a molecule. And we call these diatomic molecules. So di means two atoms in the molecule. So diatomic molecules, there's 7 of them. It's hydrogen, then there's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So 1, 2, 3, 4, 5, 6, 7. You guys got to know these. Just put a big star next to them. You have to know these. You have to know that whenever you see something that says hydrogen gas, you don't just write H, you have to write H2. An easy way to remember the diatomic molecules is if you go to nitrogen, nitrogen's number 7 on the periodic table, and then you can draw out a number 7. And then, so you see nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then you have to remember to add hydrogen to it. So that's the list of the 7 diatomic molecules. Remember, there's 7 of them. Whenever you see hydrogen gas, nitrogen gas, oxygen, fluorine, chlorine, bromine, iodine, all of these, you have to put it with a 2. And have you guys ever heard of hydrogen splitting? It's a big deal because we can't just find hydrogen atoms by themselves. It takes a lot of energy to split these molecules apart. That's because they come naturally as H2. All right, so this is a molecular element, and I'll say versus an atomic element. I can't remember who asked me this at the beginning of class. This does come up on your homework. Atomic elements, these are molecular elements. Basically, they form molecules. These are elements that form molecules. Atomic elements are basically all the other elements. Most of them, I'll say most. Because another example of a molecular element is sulfur. Sulfur in its natural state is S8, but you don't have to know that for this class. We call it a, what is it, a polyatomic element, a polymolecular element. All right. So now that we know how to name these elements and name these compounds and formulas, we can come up with what is known as the formula mass. So formula mass is just kind of what it sounds like. All these compounds that we've written their formula for, we can now calculate the mass for them. Formula mass. Formula mass just says, I'm going to take my formula and sum up the mass of everything in my formula, and I'm going to come up with its mass. So for instance, if I talk about water, that's H2O. I have to look at the periodic table to figure out the mass of each element or each atom in my compound. So in this case, what this says is that I have 2 hydrogen atoms plus 1 oxygen atom. And I can come up with the formula mass of that by just saying the mass of hydrogen and putting in the mass of oxygen right here. So essentially, I'm just saying I have 2 times hydrogen. And I look at the periodic table, I look at hydrogen. This is when we're gonna start rounding to 2 decimal places. So in this case, I look at hydrogen, it says 1.0079. I don't have to write all that out. I'm gonna go to 2 decimal places and literally say 1.0 and then 1. This 7's gonna round the second 0 to a 1. So the mass of hydrogen is 1.01. The units we're gonna use is AMU, even though in the second half of class, I'm gonna tell you to change it. Just, when we're talking about formula mass, that's atomic mass units. So 1.01 AMU plus 1 times the mass of oxygen. The mass of oxygen, when we look at it, we go to O, which is number 8. It says 15.999. When we round it up to 2 decimal places, that means this 9's gonna turn this into a 0, gonna turn this into a 0, gonna turn this into 6. We end up getting 16 for the mass of oxygen. And it should be AMU as well. But don't stress about the units because I'm literally gonna tell you a different unit in about 20 minutes. So that we can stay consistent or close to consistent as we can, and we all come up with very similar answers, if not the same answer, we're gonna use 2 decimal places. Those 2 decimal places, when we add it all up, we're gonna put it in our calculator. It's gonna give me the mass of 18.02 atomic mass units for the formula mass of water. All right, so just put a star that says round to 2 decimal places. Round to 2 decimal places. All right, so if I do some example problems, the way this will come up is it'll say, what's the formula mass of, maybe even give me your name of a compound. So some examples would say, let's calculate the formula mass of the following. And let's see if you guys can set this up and come up with the same answer. So let's say, for instance, calcium chloride. We got to figure out the formula mass of calcium chloride, which essentially means we'd have to first figure out the formula of calcium chloride and then calculate the mass. Well, let me leave some space. Another one is copper 2 sulfate. And then the third one, let's do an acid. Sulfuric acid. So let's see if we can come up with the formula of each one of these and then calculate the formula mass. Remember, we're gonna round to 2 decimal places. We're not gonna round at the end. This time we're gonna round when we're putting it into our formula. No, it's not frozen. I'm just giving you guys time to write out the formula for each one and come up with the formula mass, and then we'll go through it. Okay, guys, let's see if we can even get the correct formula. So if I have calcium chloride, what type of compound is this? Is this ionic or molecular? Can we say which one it is? Calcium chloride? Say it again for me.
Ionic.
It's ionic, and we say it's ionic because calcium is a metal. So this is my metal. This is my non-metal. So if it's an ionic compound, when I write the formula, I have to figure out the charge on calcium. Calcium's in group 2, so it has a 2+ charge. Chlorine's in group 7, so it has a -1 charge. When I write the formula looks like CaCl2. Does that make sense?
Yes.
Okay. So if this is my formula, I can then just look at the periodic table for calcium. And calcium is the formula mass for calcium, or just the mass of calcium, would be 40.08. And then plus the mass of chlorine, and I have 2 chlorines. So the mass of chlorine is going to be 35.45, but I got to say 2 times 35.45.
I'm sorry, for CaCl2, we don't put the Roman numeral in front of it because it's a metal, right? Is that my understanding of it, or?
You're saying right here?
Yes, exactly.
Because it's a metal that's in group 1 or 2. You only put the Roman numeral. So calcium's in group 2. It's always going to be 2+. So you don't have to put the Roman numeral there. You
Okay.
only put the Roman numeral for these metals in the middle.
Okay.
Okay. So when you add it all up, let's see, what do you guys get when you put it in your calculator?
I got a question.
Yep.
You said chloride is -1 because why?
So if you guys don't have a periodic table printed out, I would suggest try to figure out how to get one printed out and write these at the top. We're gonna have to use this for the rest of the semester. We gotta know that in group 7, chlorine's in group 7, when it turns into an ion, it turns into 1-. So everything I have in orange at the top, that's how I'm figuring out what the charge is. Calcium's in group 2, so it's 2+. If it's a transition metal in the middle, I have to look at the formula to figure out what its charge is. or look at the name to figure out what its charge is. So this was 1 minus, this was 2 plus. Remember, I need them to cancel out to 0. When I do that, I gotta have 2 chlorines for every 1 calcium. That's how I get the CaCl2. And when I put this in my calculator, I end up getting 110.98, and that's gonna be AMU.
I got 111.7.
That's why I say we got to round to 2 decimal places. Did you round it? Did you do these 2 numbers?
Yeah, I did same.
So let's put it in the calculator. Again, let's try again. I got 40.08 plus 2 times 35.45. So we should get 110.98.
So you don't have to use parentheses on this one.
It would be nice, but you know, the order of operation says we're gonna do the multiplication first and then add it. But yeah, if you use parentheses, you can write it out in parentheses. It'll still give you the same answer.
Okay, thank you.
All right, so let's go to the next one. So let's see if we can come up with the formula for the next one. It's telling you what copper you have. You have copper 2. So if it's copper 2, that means what? The charge is what, guys?
+2.
Yeah, that just means the charge is +2. And then you just have to know, go look on your polyatomic ion sheet to see what sulfate is. What's the charge on sulfate, guys?
-2.
-2. So these cancel each other out. So when we write its formula, all we have to write is Cu, and then sulfate is SO4. So then when we go to write its formula mass, we're saying the mass of copper, which is 63.55, plus the mass of sulfur, which is 32.07 when you round it, plus the mass of oxygen, but we have to remember we have 4 oxygens, so we have to say 4 times 16. And then we put this in our calculator, and we get 63.55 plus 32.07 plus 4 times 16. And we end up getting 159.62. And we're still using sig figs, guys, but remember the addition rule says least amount of decimal places.
Least amount of decimal places.
Right, so we're still gonna be the least amount of decimal places. And these 2 and these 4, they're exact numbers, so remember they don't count. They're saying I have exactly 2 of them, I have exactly 4 of them. So we still just need 2 decimal places in our answer. All right, let's see if we can come up with the answer for the last one, and then we'll take a break.
Mine came like 98.08 AMU. Is it 98.08 AMU?
I'm not sure. Let's see. What's the formula for sulfuric acid?
H2SO4.
H2SO4. And we know that because it's an acid, so it automatically means it has a hydrogen in the front. Remember, if it ends in ic and there's no hydro, that means it originated as an 8. So we switched our sulfate to sulfuric, and sulfate is SO4 2 minus. This is +1. When we switch them, we end up getting H2SO4. So now when we add it all up, we're saying we have 2 hydrogens with a mass of 1.01 plus 1 sulfur with a mass of 32.07 plus 4 oxygens with a mass of 16. So when I put this in my calculator, I'm saying
32.07 or 06? It's 06 on periodic table.
but remember, we got to round up. Let's see, sulfur. What's the number next to the 6? You see that it's a 5, so we got to round that 6 to a 7. So if I put this in my calculator, I get 2 times 1.01 plus 32.07 plus 4 times 16. And 98.09, is that what you said, Pawan? I think that's what you said.
I got that.
Said
Okay.
98.08 Macam.
Well, that's probably because you said 32.07. I mean 06 instead of 07.
It is in sulfur, so we have to round it. Like 32.06 is there. So
What I'm saying, it says 32.065. You round that 5 up, you round that 6 up to a 7 because it's a 5 after the 6.
in book, it is only 32.06. In your, there is 32.065.
Got you. Okay. So, like I said, it's not, if we use the periodic table I put online, we'll all end up with the same number. Different periodic tables say different things. So if we're off by like a decimal, that's no big deal. Okay. So if I don't have any questions on formula mass, let's take a break. This is all of chapter 5. So you guys have all the information to complete the homework for chapter 5. And let's take like a 15-minute break and then I'll come back and start chapter 6.
Wait, I do got a question.
Okay.
For H2, you said I'm kind of confused because how did you get H2?
Because sulfate has the formula SO4 2 minus. So if we look at our polyatomic ion sheet, where's mine? Where'd I stick it? If you look at the polyatomic ion sheet, if we look at sulfate, it has the formula SO4 2 minus. So when we put it with hydrogen, we have to switch the charges. It's basically saying that I need 2 hydrogens with a +1 charge to cancel out every 1 sulfate with a 2 minus charge.
Okay.
So, okay, that makes sense?
I have to print out. It's like I had a periodic table, but it makes sense because you had a polyatomic formula. I don't have that sheet next to me. That's
Yeah.
why.
Okay. And yeah, if you guys could print, because we need the polyatomic ion sheet. We're going to use those for the rest of the semester as well. The periodic table polyatomic ion sheet, those come in very handy. If we were face to face, I would have given you a colorful copy that was on stock card, so you guys wouldn't lose it or like